Okay. So at KNIT, you have this campus-wide license. Okay, anybody can access MATLAB and all the toolboxes in your laboratory systems, or you can also install on your personal laptop. And third one is we can also access it online also. Okay, that this is the we can install on the or we can access MATLAB online. This is first what you require. You have to create first one MathWorks account. So this is the portal of mathworks.com. You can go on mathworks.com right now. If you have not created your account, just go on this www.mathworks.com. Click here, create one, and enter your official domain ID of KNIT. So once you created your MathWorks account, so you will get one license, MATLAB license in your account. Rather than what are the benefit of that account. So let me just okay, we will discuss later. No issue. Uh, during the on-ramp courses, we can discuss what are the advantage of this one. So anybody can access the MATLAB. You can also install. So we are also going to see that how you can install that particular MATLAB into your system also. So once you log in is complete, then just here your name will be mentioned in the MathWorks account. You have to just click on my account here, and in the my account section, just click here manage product, and here we can download this option. So from the 100 MB file will be downloaded for you according to your we can say if you have Windows operating system or Linux or another system. So just run that particular uh, installer, and it will ask again to login. Again, login into that in Networks account, and you are able to install that particular uh, or it will give you the list of toolboxes. So according to your domain, you can select out the toolboxes. As you know, in the MATLAB, we have more than 100 of toolboxes, but uh, due to your system limitation or your case, we can select the toolboxes. Okay. So this is how you are going to create your MathWorks account using the www.mathworks, and how you are going to install that particular MATLAB into your system using the download option. Okay. So further, if you try, I will also share my mail ID, or if you have any issue, so uh, I will assist you. No issue. Okay. So once you sign in into your Mathos account, then here in the left hand side, you will get these type of options. Like you will get also if you are using the MATLAB online from this option. So we can access MATLAB online also, and MathWorks provide you the 5 GB. We can say the this space or cloud-based space where you can save your uh, program here. Then this section is my courses. If you just click on this my courses, so you will get also some on-ramp courses plus some advanced courses. It is free for all. Okay, so to do learning that MATLAB, Simulink, and other toolboxes, so we can complete these courses also. Okay, so these are the all are the certification courses. So once you are going to create or complete these courses, you will get the e-certificate from the MathWorks. Okay. So for more detail for these courses, we can also visit on this link www or matlab.mathworks. Otherwise, you can access these courses or MATLAB online from your MathWorks account also. So as I discussed that anybody from faculty, staff, student can access MATLAB using your domain ID. These are we have discussed the cell-based learning courses like MATLAB on RAM, Simulink on RAM, or machine learning more than 10 courses are free, and some advanced courses also free for you because you have the campus-wide license. If you visit in your MATLAB account, so you will find out all the courses. Now, come to the, may I know, sir, most of the students are from which year?
Sir, final year students.
Okay, all are the final. It's good.
Yes.
So already you are working on the MATLAB, okay?
Yes. Yes.
So aware of the MATLAB and Simulink. So I'm not just not going from the scratch. So we will discuss that how what are the new features in the MATLAB and how interactively you can work with the MATLAB. Okay. So here, as you know, these are the some application area of the MATLAB. Like MATLAB could be used for AI applications, so we can build some type of AI applications. Here is one example of deep learning. Basically, it is the image classifications. So if you want to start your machine learning or deep learning with the MATLAB, it is always easy start with the MATLAB. So we can start our deep learning or AI application with the MATLAB easily. This is another application of MATLAB, like MathWorks provide you complete solution. We can also use for our IoT applications. How? This is MATLAB where we can write our some type of desktop algorithm, or we can also write some sensor algorithm. Okay, this ThingSpeak. Basically, what is the ThingSpeak? ThingSpeak is a cloud-based service provided by the MathWorks. As you know, the MathWorks is the with the product. This service works and for education. So anybody can create here account, and for that you require only the MathWorks account. So once you are going to visit on www.thingspeak.com, so just note down it. So I'm not going to switch to the thingspeak.com right now. So if you are going to visit on the thingspeak.com, so first you need to create your account with your MathWorks account. Okay, then during the your MathWorks account creation, it will ask describe yourself like commercially or education. So you have to select education account. Okay, so this is free for education. So what do you think speak? Basically, it is a cloud-based service where you can aggregate or send your data from your hardware in the sense from different type of sensors. You can send your data from your smartphone, Arduino board, Raspberry Pi, in ThinkSpeak. And once you require, we can also perform some type of analytics on my data, or we can take some decision based on the data. So MathWorks provide you complete solution that we can build the application related to IoT also. Autonomous system, we can design and simulate this type of autonomous system. It is not just animation. Basically, here is, we can say, some driverless vehicle is running here. So this type of scenario, or we can say this type of system, autonomous system, we can design and simulate with MATLAB and Simulink. For in the field of automatic field, like we have the Simulink, and on the top of the Simulink we have a Simscape we are going to discuss. So we can also design and simulate like electrical vehicle or system here. So this is this electrical vehicle with different environment conditions. We can design the controller for that particular vehicle, and parallelly we can visualize the result. Another application for robotics, like we have the robotics toolbox, so we can design and simulate different type of robot or UAV or manipulator with this, and we can also interface the some with the help of ROS toolbox. We can interface some type of robot, and we can acquire the data, or we can send the data, or we can deploy that particular program on robot also. Like, as you know, the MATLAB and Simulink we can use for multi-domain design and simulation. So here is one example of we can say it is a wind turbine. Okay, so as you know, it is a combination of mechanical as well as electrical system. So multi-domain simulation also possible here. this is for an aeronautics, like this is one toolbox, aeronautics toolbox. We can also create this type of scenario, like if we want to test our aeroplane related data. So it is landing of the airplane. So this type of scenario we can also create. So these are the some application area. Apart from that, we can use MATLAB and Simulink in for various applications. Now introduction to smart system. So how you are going to make your system if you are going to as a engineer design a system. So what is smart system head and how you are going to implement that particular intelligence in your system. So this is that the industry world is changing with the emergence of smart industry. Now today production machine you know have some type of highly integrated mechatronic system. Some portion it have some hardware or software like embedded software. So how the MATLAB and Simulink could be useful to make this type of smart design. Like here, models which can predict based on our data here. So tomorrow session we have on the machine learning. So we are also doing or making some type of machine learning model for prediction purpose. Apply models and simulation to control complex systems. Suppose you want to develop some type of control complexity. So in the MATLAB or Simulink, we can create that type of scenario, whether we are going to for some type of complex system, for example, electrical vehicle or power plant. So before going to the hardware, we can simulate that particular system into a Simulink environment. Develop and implement embedded software without manual coding. Once you created your system into Simulink or MATLAB, code generation also possible. So no need to write your 1,000 line of codes. So we can directly generate code for the hardware implementation. So code generation also possible here. So everybody know what is MATLAB. So as you know, it is a high level language. High level language means it is very user friendly and it provides you very interactive development environment, whether you are writing your some type of algorithm or solving any problem. So basically it is used for numerical computations, data and visualization of your data, fitting of your data, and we can also write some type of algorithm according to our domain, and deployment also possible. So we can also share our algorithm into a different form. So these are the more capability of MATLAB, like this is mainly used for the data analysis, whether you are going to explore, model, and analyze the data for graphics purpose. That we can visualize our data into as a different type of plotting options is available, like line plot, discrete plot, scatter plot, or histogram plot, or other different type of plots is given. We can use MATLAB for writing our desktop algorithm, or we can write for the embedded hardware also. Using MATLAB with other languages, so it is also possible that we can interface MATLAB with other language like Python, C, C++, or Java, or we can say we can import, export the functionality with other languages also. MATLAB in the clouds, so we can also run MATLAB program or into the clouds like some public cloud, AWS or Azure. Perform large scale computation in parallelism if your algorithm or you are working with one type of simulation which take lot of time to. So here we or GPU or cluster on clouds also. So it will reduce the computation time. Hardware interfacing, so we can connect different type of hardware. It could be your low cost hardware. So what is the category of low cost hardware? So anybody can access these low cost hardware, like my mobile phone, Arduino board, Raspberry Pi. So these are called the low cost hardware. So we can make some type of project using these low cost hardware. But some we can say some industry standard hardware also we can connect with the MATLAB, like your laboratory hardware, which like your oscilloscope or some data acquisition devices, or we can say the devices from the vendor like National Instrument. So these are the some, or for example, we can also connect our webcam. So different type of hardware interfacing is possible with the MATLAB. Okay. Web and desktop deployment. So if you write something, or we can convert it into an app, and that particular app we can share to the other user also. We can convert it into exe file, or from our algorithm we can convert the library of other languages also. So these are the capability of MATLAB. Further, now how the industry are using MATLAB. Like this is a one case study from the Ether Energy. So basically, Ether Energy developed electric two-wheel scooter and charging station using model is design company. So design and produce India's first intelligent electric scooter. So what is the solution they have used? Use model based design to simulate and optimize the scooter design. Please unmute yourself. There is some noise. Let me check if someone is, I think. अबे हमारे ईयरफोन जोड़ सकते हो। हाँ तुम्हारा तो शोल्डर का सब बात नहीं जोड़ेंगे। शोल्डर तुम्हारे पास है क्या फीचर? वही तो यहाँ तो क्या है? हालत आसान उसमें दिखा रहा तुम्हें। Okay. So they basically use this model-based design approach and generate the production code, and that code is deployed onto that hardware also. So what is the result they have achieved? So design alternative ability in weeks, not months. So using the model-based design, basically they reduce the time, and finally we can also there what is the different advantage and error also. Testing time reduced by 50%, and field issue rapidly resolved. So because they test this electric vehicle with different environment conditions by providing. So this is how, this is one example. So a lot of industry or type of industry are using MATLAB and Simulink to building their product or applications. Okay. This is for you that student challenge. What is student challenge? It is one type of competition. MathWorks is organizing it. So they basically give you, if you some type of challenge in the form of project, and it also help out that if you are going to participate in this, so it will also provide you some type of assistant, like some free MATLAB software and other document also, and there is some cash prize also there. So for more information, we can search on the MathWorks site, or any browser, student challenge by the MathWorks. This is same, that this one type of student competition is sponsored by the MathWorks. So every year or after 6 months, they develop some type of or give some type of challenges to the student. This is another student competition, prepare student for the career. This is one video from they have developed this using MATLAB and Simulink or boxes. So as you know, MATLAB has more than 100 of toolboxes. So we can divide all toolboxes into two main categories. This is MATLAB in the blue part. As you know, in the MATLAB, we are going to solve our problem in of scripting approach. Okay, and here, as you are aware, this is Simulink. It basically it is a GUI-based environment used for simulation and model-based design. These are some application based product, whether we are going to work in system So in this group, we have the values toolbox, control system toolbox, or fuzzy logic. It has the signal processing and communication toolboxes, image processing and computer vision. Using the test and measurement, we can interface industry standard hardware with the MATLAB to acquire the data. And MATLAB Simulink could be used for finance field also or biology field also. This is basically technical computing workflow if you are going to solve the problem. So first we are going to access our file or our data. So it may be possible that your data in different type of file, like Excel file, or you have your audio data, video data, or you have your data in some type of text file. So it is, we can say it is possible that we can access our data from different type of file into MATLAB. Second option is that if your data have in the one type of database, so it is also possible that we can interface that particular database to the MATLAB to acquire our data. And third one is if you want to acquire your live data from the sensors. So it is also possible that we can just 1 minute. Just second, sir. Yes. Yes, Amit sir. Now it's hello. I
Yes
am
sir.
audible.
Yes sir, but voice बहुत lag कर रही है sir, थोड़ा maybe कुछ network issue हो.
Now it's fine, sir.
Yes sir, अभी तो fine है sir, but बीच-बीच में sir lag करती है sir.
Okay, maybe some network issue there, but it will okay.
Yes,
okay,
sir.
so let me no issue, sir. You can unmute and interrupt me on this. Okay, sir.
Okay, okay,
If there is some technical issues, sir. Okay.
okay, okay sir.
So this is that it is possible that we can import our data from different type of file database, or we can access the data from live hardware. Live hardware means different type of sensors. Once you brings your data into MATLAB environment, now it's our turn as a researcher that we can use MATLAB and other toolboxes for data analysis and modeling. We can write the algorithm according to our data. And we have the option that we can also design some type of apps. Once we are satisfied with our result, now MATLAB provide we the option that we can share our work into different type of file format. Like we can convert it into as a PDF file or doc file, or if you want to publish your result, that directly we can generate the HTML document also. If someone is working for the hardware, so code generation is possible. Suppose someone is working for the electrical vehicle or mobile technology, for the different hardware or different type of controller, code generation is possible. Directly we can deploy that particular code onto the hardware. So no need to write the code here. Then application, if you develop some type of applications, so we can share that particular application as a MATLAB standalone file, or we can generate the library of other languages also, so that we can use that particular algorithm with the in other software language library also. So this is the technical computing workflow of MATLAB, and this is automate. That means if we are not satisfied, or we are working for any client, or so we can again go back, we can again access the data, we can change in the algorithm, and again we can share. And the whole things we can do in a single environment. This is MATLAB. Okay. Now we are going to see how interactively we are going to import the data into MATLAB, and without writing the code, we can also visualize that particular data from different type of files. So let me switch to MATLAB. So as you know, everybody is aware about the interface of MATLAB. So this is the latest version of MATLAB 2021B. And this is the command window if someone is new. So we are going to enter here command. This is the current folder in which we are going to save our program. So basically this is the current directory path of the MATLAB. And here is we have the workspace. So workspace basically we can say is a temporary memory. So that we can see our variables which are declared to the MATLAB here. Okay. Now to import your data, we have this import data tool. So suppose I have my data into some type of Excel file, or it could be your image file or video file. So without writing the code, by just clicking this option import data tool, we can import our data into. Let me just click on that. So it will open a import data tool, and these are the file formats supported using this option. So we can import our audio data, JPG image, text image, video, different type of file option is possible. Right now, I'm just going to import data from the Excel file. So let me just check. I have my Excel file in this path and maybe in this. In this file. So this is the gasoline folder. I have one Excel file here. This is .csv format. So I'm just going to import this file and just select, and I'm just going to click open this one. So just it will take little bit time. So before importing, it will ask me some option. So this is my import file. So import, we can say tool is open, and it is asking me some option that this is my delimited. What is a delimiter? So if in your file you are putting some comma, space, or semicolon, so this is called the delimited. Okay. Now, by default, my original data is in the table form. So by default, it will import as a table here. Okay. So now, so actually some processing is going on. So my data has been imported. So it's taking some time. Okay. This is my original table. So in this data, I have some gasoline price which are changing in different countries in different years. Okay. So by default, if I'm just going to click on this green tick and my table name is gas price, so it will import into my workspace. So let me check my workspace. The whole table has been imported into my workspace. Okay. So now in the import data tool, I have the option that I don't want to import whole the data. So I can select randomly, like I want to import this column, only this column or this column. So I want to analyze the price of three different countries only. Okay, so the price from the France, Mexico, and USA. So I can still select that particular column from that file, and if I'm just going to click, so only this table will come extract from this one. But I have another options also that I can also import it as a column vector. So what will happen? So all the column will become a separate variable into my workspace. Okay. So if anybody have question in between, so you can unmute yourself if any step you are not going to get. Uh, so this is that I have just selected this column vector and I want to import these four column but separate variables. Now one option is here that variable name row is here one. So it will take my variable name from the row one. In the row one, I don't have some meaningful name here, like it has a variable one, variable two. But in the row five, I have some meaningful name like year or France or Mexico. So I can change it that take the variable name from row 5. Now I'm just going to click, and these import my data as a whole table. This is my whole table, or I can extract the column as a separate variable. So depending on my requirement, it provides me the flexibility. Okay. Now, how you are going to visualize your data? So to visualization of your data, I have here basically three tabs: plot, apps. So in the plot tab, I have different type of plots is available. It could be your line plot, or some discrete type of plot, or 3D plot. So every plot has its different command or syntax. If I don't want to use that particular syntax, so right now I can select my variable from workspace. So first I am going to select my x-axis variable. So all the plot supported plot has been enabled here automatically. Okay. Now I'm just going to hold the control key and selecting rest y variables like USA, Mexico, and France. And I can just single click on any plot. So it will give me relative plot. So right now I just want to plot it as a this one. So according to that, that means without writing the code, I can import my data. But as you know, to import your different type of data like image or Excel file, I have also command based approach. So I can also use the command. And to visualization also, we have to declare our data, and we have the option of plotting for different type of data. So now whatever I have done to importing my data into MATLAB, so now it also provide me some type of option that I can also generate the code from that. Okay. So just let me just. So here once I select or and click on that particular plot, automatic command is pop up here. So if I don't know the syntax and command of the plot, by just doing, and I can now learn what is the command if I'm going to. So it is showing that hold on, and hold on. So it will give me the result. Now this plot is not so meaningful. So I can insert different type of labels, legend, and I can also edit that particular. So now I'm just going to insert some options, like I can insert some X label. So it will, I can write anything on the X axis, Y label, or I can insert this legend options. So manually without again, so every option has its own command, but without writing the command manually, I can insert all the options here. So now I can specify that belong, this blue color belongs to the price of the USA, this is belong to this one. So I can just decide this one. And if you are going to edit this plot, so you can just click on this one, and we can also change the color of any specific plot. And here after my changing, code generation also possible. I can generate the code whatever the changes I am going to do. So without writing the code, I can do the thing automatically, and code generation also possible from this figure window also. So if you require this particular code for automation purpose, so we can also generate the MATLAB code. So this is the code for whatever the changes I have made in this one. Okay, the code generation is going on. it will not this much time because I was open my MATLAB since morning, so it's working slow. So this code has been generated, and this is the code for changing in the, this one. I can use this for automation purpose. Further, in the import tool also we have imported our data. So if you want to learn the code that how you are going to import the data from the table, so we have the option that we can generate the live script or any type of function from here also. So that we can understand that how, if we are going to write some type of program, so how we can import the data from the table. So there is read table command is there. So using this, how we are going to use. So we can learn uh, the code also, code part also. But we can say that MATLAB provide us some interactive way so that we can interactively work with our data with the help of these tool, and code generation also possible here. Okay. So this is how interactively we can import our data. So let me just clear the workspace. Now,
Sir,
yes, sir.
sir, what is the difference between normal script file and live script file?
Yeah, just we are going to discuss. We are going to discuss, sir. Okay.
Yes, sir.
That is the next topic, sir. Okay.
Yeah, okay,
So
okay.
this is my live script. Okay. So now let me just know. So next topic is, so I'm just not going to on the PPT every time. So we can just different type of data type and variable. So as you know, you are aware about the different type of data types and how we are going to declare the matrix. So I'm not going to in the detail. So that these things you can learn from the MATLAB on RAM. Okay, if you have still any issue. So what are the, this is the way that we are going to declare the matrix, and these are the some elementary functions is available that we can use directly. These are the inbuilt function within the MATLAB. Further, this is live script. What is basically live script is, you are also writing your program into the editor. Okay, this is simple editor. But I think nobody have used this live editor or live script. Okay, so what is the advantage to using this live script? So, sir, everybody have the knowledge, or student know this editor part, sir, to writing the code.
No, sir, not every student aware about this editor part.
Not this, not live editor, previously, sir. So they are doing some programming in the lab using this live, this script. This is the script, simple script. Not aware.
Not, no,
Okay,
no, no,
okay,
sir.
okay. So what is this? There are two function here, or we can say two things here. One is simple script, and second one is new live script. Okay, so if you are going to write your program, lengthy program, so it is not a good idea that we are going to write that particular program onto the command window, because we cannot save that particular program, we cannot edit. So this is the drawback of using this command window. Okay, now we can write our program. This is editor, or we can say this is the old editor. So we are going to, if we are going to provide some command, we have to write our command in this percent sign. Okay, then we can write here a equal to anything 1 2 3, and b equal to 3 4 5, and we can sum a equal to a plus b. So we can say it is one program. So if you want to divide your code into different sections, so we can also break the sections here using this break sections. But here, if you want to write some theory part, so you have to mention here, like you want to include some theory equations like sine, omega, or theta sign here. So if you want to insert some theta sign or some type of special symbol, so it is not possible that we cannot find any type of symbol in this simple editor. Okay, So we have to copy paste from the any browser or the WordPad. So here everything is commented in the green color here. Okay. So we cannot write some type of real document here. And so this is the drawback of this editor. Still it is working. It's fine. So everything we can write, we can make the program, but we require some advancement. So what MathWorks did in 2016 A version, they have included this live script. Okay, still it is working. So if you are going to write your program in the live editor, it will save it as a .m file. But if you are writing your program into this live editor, so it will save or its syntax is .mlx. So let me just parallelly compare it and what is new in this live editor. In the live editor, basically we have two parts embedded here. One is code part. This gray strip is called the code part. If you are writing some command, so you have to write in this code part. And another one is this is your text part. So we can toggle between text part as well as code part. If you need to write some theory part, so we can write in this text part, like for example, this is my DSP lamp. Okay. Now I can make this text as a some real text. This is DSP lab and this is my experiment number 1. No need to insert that percent sign. I can write real text here. Okay. So according to that, I can write anything. So it will not execute in the program. So as a teacher or you are doing your laboratory work, so we can, it is better that we can write our program in the live editor. Now, if you want to insert code part, so just toggle between this code part here. So it is a equal to same thing we can write 1, 2, 3, 4, 5. So everything, if I want to execute anything, so I can write anything here. Okay. So basically two part is here. Now this we have this insert tab. Suppose you want to as a teacher or you are writing some type of paper and you want to include some type of equations which describe your code. So here if you want to mention anything, so you have to write here in the percent sign in the within the code part, but here in the text part we can insert anything. Suppose I want to insert here a one equation equal to sine 2 into pi. So if you are using pi into code part, so as you know pi is the code part, but in the theory part you are going to use the symbol. So in this insert tab, in the equation option and the equations, we have we can insert different symbols in as a theory part. So whether I can insert omega, theta, pi. So from here we can insert anything. These are the some special type of structure we can also define our equations using this one. So this is basically the difference in one difference that text and code part has. Now we have some extra, we can also insert some type of images in the document in this one. If you want to describe your theory, so we can insert image or hyperlink also. Different type of options is possible here. Now in the live editor, we have this control panel. So we can also insert some type of numerical slider. So numeric slider means we can define our value with the help of this slider or some drop down menu, check box, edit buttons. We have seen that how we are going to use the plotting. So if you are declare your data here, so with the help of these task panel, we can solve our problem interactively. This task panel we can insert into this live editor, and without writing the code, we can solve our data, our problem. Like different type of task panel is given, like for optimization, if we are working in the control system. So these task panel we can insert here and easily without writing the code with the help of this one. If okay, so from here, if you want to use your any type of plot, so from here also we can insert this create plot and we can just select our data and we directly just by clicking here, we can create that particular plot also. Other task, if you ask, we can insert this clean data, missing data, or we can also make data or smooth data or make it could be your signal. Okay, so easily we can insert this clean missing panel and without writing the code we can apply different type of algorithm. So interactively we can solve our problem. If we are going to save this file, so by default it will save h.mlx. But if your colleague or friend has the old version of MATLAB before 2016, so still we can also save it into .m file. So we can open our .m file into, if you are going to right click and open as a .mlx, or we can save .mlx into .mlx. Doc file, if you want to publish your file, you want to make some web page, so we can select this one. So this is the sharing, different type of sharing is possible here. Okay, so this is that understand that what is the difference in live script and this one. So anything we can just create. So just we are going to take one example so that already written script is there. Okay, so let me just open the doc. So if you are going to read the document of the MATLAB, we can type this doc command. So or we can just click on this question mark help, or let me just type this doc command. So it will open the document of the MATLAB. Okay, MATLAB and other toolboxes. So how you are going to learn? So there are many resources to learn the MATLAB. Like one best resource is its document. So if you want to learn MATLAB, so we can just click on this MATLAB Simulink, and there is some example is given. So step by step we can follow that particular. So let me just open this MATLAB. And here the MATLAB document is divided into theory part. This is example, and these are the different type of functions is available. So in the example, let me just I want to discuss you the plotting options. Okay, in the previous section we have seen that without writing the code we can do some type of plotting. But this example is given me, and in the document this we can say the theory part. But what is the benefit of this? I can open this document as a live script. So I'm just going to click on the open as a live script from the example. So it will, I can select anything. So it will open into live editor. This example will open into live editor. So what is the benefit of the live editor? So I can run that particular live editor, and here now I hope that you can also create this type of document. Okay, now this is the 2D and 3D plot. This is the line plot, and in the line plot it is given that line x value of x range 0 to 2 pi. This is the plot command, and we can also provide the x label, y label, and z label. So this is that how we can create our program into live editor. Okay, so I'm not going to detail. Everybody know the 2D plot and 3D plot. If you don't know, there are direct command for the 3D like x, y, z, that you are going to provide 3 and different type of plotting options is there. Okay, rest thing for hands-on practice, you MATLAB on RAM course. Okay, so first do that particular on lab course if someone is want to practice on the type of this one. But thing is that this is how this live editor is useful for you. So we can divide whole the program into different sections using this one. And what is the main advantage of this one? We can we can also suppose if I'm just going to click on this, so I can run whole program one time. But as a initial learner, if I want to run only this code, so I can just select this particular section and I can click on this section, sorry, run section. So only this section will run here. And alternatively, I can also click on this blue strip. So only this section will run and it will give me the output on the same window. But in the case of simple script, as you know, this figure window comes separately. So I can just click on this option, output in line. So if I want, I can display my output below of the code, or I can select this one side of the code. Okay. So like this, let me just run whole the code. And another benefit is that I can save my output as well as my code part, and I can save this into a document. So if I am a teacher and I want to or I am a student, or I want to create some type of file, so I can just save it as a PDF document and I can explain the theory. So this is one example. Apart from that, if we can also teach other subject also by making this type of live script. Okay. Then in the live script, we can also insert this X label interactively, Y label, Z label, and automatic code will be. So X label is, suppose this is my time, and Y label is here. If we are going to just click on this one. So this is how interactively we can just going to work. So this is that how we can import the data and how we can write the our program into live script. What is the difference in the live script? These are the new, say, new features that you have to learn. Okay, part I'm not going to very basic that how we are going to add the number, or this one. So you will learn that particular thing from the MATLAB on RAM. Okay. Now this is app. So as you know, these are the apps is available if you are working in some type of specific domain. So in each toolbox is definitely you are getting the type of app. So tomorrow we are going to discuss that how these app you can use to solve again that without writing the code. Like if you want to develop some type of machine learning model, so with the help of this machine learning, if you want to do some type of filter design, so in the signal processing and this group, we can find out the filter design app. So these are the app without writing the code, we can solve the problem. So this is further uh, going to take a look on a different type of file. This is .mx file. We have just uh, used it like different type of 2D and 3D plotting options is available. Whether we are different type of options is available. This is one example of 2D and 3D. So for 2D, as you know, if you want to display your graph with the help of the command, so otherwise we can directly declare our data, and from the workspace we can visualize the data, or in the live script we can just insert the create plot panel. If you want to write your own function, so this is the code for writing your own function. So like you are going to start with the function name, and this is input. So let me just, it is important, and let me create one type of function here. So suppose you want to write your own function. Own function means suppose some command is not available in the MATLAB and you want to write your own command. So this is my output. Data is M, and here your function name is like my fun. I've just written my fun, and this is A comma B, and I am writing this function. It will give me the multiplication and sum of two number. So here I can just save this as a M equal to A into B and S equal to A plus B. So this is the function I have created. If I am going to pass two value in this function, so it will give me the multiplication and sum of two number. So I can save this particular function, save as, and I have to keep this function name is same as my file name, my FLX. Okay. So I can call now this fun, my fun, and I can pass two value 4, 5. So by default, it will give me only one answer because I know this function can return two value. So by default, it is giving me the first value. If I want to retrieve two values, I have to mention in the left hand side two value, anything G, J. So I know what is G, multiplication of two number, and what is J is sum of two number. So this is how we can create our own command or function within the MATLAB. Okay? This is all about the file. This is your function file, and if you are going to automate your program, so we have the simple syntax if and if else and or we can use the for loop here. Okay, here is a for loop or switch case or while loop. This is easy to use in the MATLAB. Let me just discuss one example through which we can understand the this. Just I'm just going to only discuss one example. In this example, I am just going to apply for I equal to 1 colon 20. 1 colon 20 means my value of 1 will be declared from 1 to 20. 1 colon 20. 1 colon 20. And if this condition I am going to apply, if I equal to 5, it will continue. And I am ending if statement, and here I am ending for statement. So this one, that in the simple syntax we can use our if statement, for loop or while loop. So this is that how we can use for if. So it is telling me that you are going to learn and once you are going to complete your MATLAB on RAM this certification course. So this will helpful for you to complete this one. Okay. So we are going to discuss that this course will start from the scratch. So let me just close it. So I can also close it. So this is just I want to discuss new feature of the MATLAB because we have the time limit and we have to move on the Simulink. So please, if you have any question from the this MATLAB environment, so you can ask. So we can take some question from different. Any question? No hesitation. You can speak in your language. Okay. हिंदी और
स्टूडेंट्स
इंग्लिश.
किसी का कोई क्वेश्चन हो अभी तक डेटा कैसे इंपोर्ट करते हैं लाइव एडिटर एंड फंक्शंस कैसे हम लोग डिजाइन कर रहे हैं इस रिगार्डिंग किसी का कोई क्वेश्चन हो तो यू कैन आस्क ओके ओके सर आई थिंक स्टूडेंट्स हैव नो क्वेरी
Okay. So just we are moving to some Simulink part. Let me
यस सर
just. So let us use the Simulink. As you know, you are aware about the Simulink. So basically, Simulink is used for modeling and simulation purpose for dynamic system. So dynamic system means your system belong to any domain. It could be from electrical or multi-domain systems. We can also implement our MATLAB algorithm into this Simulink environment. So there are some blocks is available for which we can write or include our own algorithm to control that particular hardware. So Simulink, again, this is used for design, simulate, and deployment. Again, if you are going to simulate, it is also possible from the to write the 1,000 line of code. So directly we can deploy that once we are satisfied the performance of our system. So Simulink could be used to model every type of project, wireless communications, motor, if you are working as a power system engineer or signal processing engineer, or robotics field, or we can say image and computer vision and IoT project. We can also build with the help of this Simulink library. So these are the applications of. So what is the requirement of this Simulink? Because if you want to, as an engineer, you want to develop some type of system. So as an initial, or it could be that you want to design and simulate some complex system. So hardware, right now hardware availability is not there. So it is always better that we should simulate our system in a we can say in the software environment, so that we can also verify our system with different environment conditions, that my system how it is behaving and with the real world. Otherwise, if you are hardware, there is some error is given, so maybe there's some lot of money and time wastage is there. So it provide you the environment in which, like in the traditional development process, if you are using traditional development process, so your requirement, so for your requirement, basically your requirement are in the form of that some type of document which is difficult to analyze and manage. Now, like we can say it is in the form of some paper specifications. Now, if you are working with other different multi-domain system like electrical component designing, algorithm designing, for this you are going to have some other domain like mechanical component is there and embedded software is there. So what will happen if you are going to assemble multiple domains? So maybe some type of error occur and during the integration test. So this is called your traditional method, and here you have to manually coding. You have to do time consuming. So we can say this is a traditional method to design a system. But what is model based design? What is model based design? Basically, your requirement are linked with your design here. Okay, like detail is added from a specific domain to refine the model. Refine the model means basically what is meaning by model based design. So you can understand in one term. During the if you are going to develop some type of system, so in the model based design, your system is in the center of your development cycle. Center means every time this is your main component that you are going to concentrate on your systems. So in this model-based design approach, design is domain and refine, like your requirement are directly related to your models. It could be your mechanical system or electrical systems here. Real-time test and testing also possible. That parallelly we can also in the Simulink environment, suppose you design some type of controller. Okay. Now we can test and verify this controller by generating the code. We can directly in place of that controller, we can replace that controller with the help of the code. This is called the SIL. So there are four terms there: MIL, model in the loop; SIL, software in the loop; HIL, hardware in the loop. So we can verify our system in different conditions. Okay, and once you are satisfied, code generation also possible here, different type, no need to write the 1,000 line of code. So during your process you are going to use this model based design, because every time this model is the center part of your development. So this is model based design. Now, little bit think speak for IoT project. So I have already discussed you that this is the MATLAB and thing speak, and we can connect that smart connecting devices. So if you will take time in the last, so we will visit this site, and I can just suggest you how you can start your IoT project with the help of this thingspeak.com. So there is we can say some step by step process is given for us, and we can learn more about from the site. Okay, so this also we can use for building of IoT project like ThinkSpeak for energy monitoring, ThinkSpeak for smart farming. We can also collect, analyze, and act on the data. So in this ThinkSpeak, we can make around 4 channel, and there are some channel means where we can save our data. So there is some community is available on the thing speak. So if you don't have your own sensor data, so there are some public channel also available. So we can collect that data from that public channel. We can access that data and we can analyze that data with the help of the MATLAB here. Okay. Now we are just talking about the how you are going to make your system as a smart system or your industry as a smart industry. So one term here is digital twin. It's very important for an engineer. So what is basically digital twin? Its definition, maybe this digital twin is an up-to-date representation of a model of an actual physical asset in operations. So what is meaning by this? What is digital twin? If you are going to make some virtual uh, of systems or component of the system, uh, second to design one type of controller for the plant which can operate that particular plant. Okay, plant or any we can say any component or any machine. So now what are you doing? Suppose you are going to create the virtual of that plant into Simulink environment, and you are taking the data, live data using the sensor into the Simulink, and you are going to verify how your controller is behaving with the real data. So this is called digital twin. So it is very helpful. Uh, Digital twin. So we can create digital twin of a component, system of component, systems of systems. So it has wide applications it could be used for evaluate the current condition of asset, like predict future behavior of the component, refine the controller, or optimize the operations. For example, this is one example of or one application of digital twin. Like for it could be used for predictive maintenance. What is meant by predictive maintenance? As you know, in the industry there are a lot of machines using, or maybe it may be that if suddenly any part of the machine or any system is failed, so what will happen? Maybe that particular machine will not work. But what about in the insensitive case, like where maintenance is generally not possible easily, or maybe if any part of the machine going to down, so maybe loss of money or maybe loss of life of the human. So in that cases we can use this digital twin for predictive maintenance. So what will happen? Suppose this is one machine which is digging the oil from the ground. So we can access the data, or we can directly sense the data from any part of this machine. Like here in this example, this is pump. So we can continuously take the data from the pump. We can feed digital twin. What is digital twin? This model is built in the Simulink, and we are gathering the data, live data from the sensor into this digital twin model, and we are going to perform how this, and we can also create different type of scenarios from that data. So that we can predict that if the output of that particular component is in that range, so we can decide that particular part of that component is going to under maintenance, okay, or it is going to degrade. So this is that how we can, based on the data, one type of tool in MATLAB is predictive maintenance toolbox. Okay, so predictive toolbox. So we can use MATLAB and Simulink for predictive maintenance also. Now, before going to discuss this demo, basically I have just taken this demo so that you can understand the workflow and how you are going to design Simulink environment, and what is the difference in Simulink and REST, what is Simscape. Okay, so well, just let me switch to the MATLAB here, and how you are going to start your Simulink. So we have this icon here to start your Simulink. Alternatively, we can type the command here, Simulink. Okay, so let me just launch the Simulink. So this is called the Simulink start page. Now we have different template is available or options is available. Like we can create a blank model. So it will open a some type of model window. Here is different template is given related to your domain. We can just open. If you are working into DSP system toolbox, you want to create some type of model from the DSP or embedded coder, or you want to work on the communication, so we can also open these template. So what is the difference in different template is given here? Okay, so as you know, we are going to make our model using the blocks. Okay, so using the blocks for different applications, there are some type of solver work in the background. Okay, you have heard some type of solver in the mathematics like OD 45, Range Kutta, different type of solver is available. So it may be possible for different domain, we require different type of solver. Okay, so if I am working as a, I want to design, simulate some communication system, or some other domain maybe require some type of other solver. So if you are not aware which particular solver will work for your system, so we can directly open that particular template. So there is some pre-built setting is there. So we can start using this template also. But right now, I'm just going to, I think everybody is aware about how to start with the Simlink. So I'm not going to, sir, everybody have
No,
practice
sir.
for?
No, sir. Please explain, sir,
Okay, okay,
how we
okay,
design a model in Simulink.
okay, okay, okay.
Yes, sir.
So I'm just going to open, and second thing, I'm not just going to discuss it again. So right now I'm just going to give two practice or on-ramp courses. One is MATLAB on-ramp and second one is Simulink on-ramp. So to learn more on this Simulink, if you are going to install the your MATLAB and just launch the Simulink, so here we have Simulink on-ramp courses. Okay. Further, after completing the Simulink on-ramp course, we have the control design on-ramp with Simulink and Simscape on-ramp, circuit simulation on-ramp. So 5 courses are available here. So how you are going to complete your Simulink on-ramp certificate from this MATLAB. So MATLAB on-ramp certification you can browser without installing the MATLAB. But Simulink on-ramp you cannot complete without installing the MATLAB. So first you have to install your MATLAB in your PC or lab computer. So from there you can just open it, Simulink on-ramp course, and it will teach you everything. Okay, so this is for your hands-on. This is you are going to complete. Not possible tomorrow you have also, but at least try MATLAB on RAM. If you have installed MATLAB in your system, so some part try to complete 10% or 15%. So this is about the Simulink on ramp. You can learn more about this one. And these are also around 2 hour courses, and you will get the certificate after completing this one. So I'm just going to start a blank model. Now this is called the model window. Okay, this is called the model window or designing window. Now to designing any component, I require the any system, I require the component. So here I can just open this library browser. So using the library browser, I can just open the my component library. Okay, so alternatively, I have the command if I want to directly open this library. So using this command also SL library browser. If I'm directly want to open the SL using this SL library browser command also, I can launch the library Simulink library. So this is called the library of component. So here you can see this is the library of basic Simulink. Okay, so this is whole environment called the Simulink. Okay, this is the because this is the base product of this environment. But on the top of this Simulink, we have also other toolboxes also or library like audio. If you want to or design some audio system, so in this we have the audio library. Okay, but this whole environment is called the Simulink. So in this basic Simulink, we have some basic components like delay, multiplier. Here, if you want to generate your signal, so in the source category, we can generate different type of signals, chirp signal, or it could be your signal builder. In the sync, if you want to display your result, so we can display in the display component, it will display only numerical value. If you want to display as a scope, so it will display your result as a time varying signal. Okay, now here we have the user defined function, so we can also insert this S function or MATLAB function and we can apply our algorithm into Simulink environment also. So if we are going to access, these are the math operations. So this is called the basic Simulink library. Okay. Now, how you are going to design your system for an engineer? Suppose you want to develop one small circuit, RLC circuit, and you want to verify what is the drop of uh, across any capacitor. You want to apply some type of voltmeter, but there is no component is available here related to your voltmeter or your battery, or we can say from any RLC circuit is or RLC component is not available in Simulink. So how you are going to design? So this is main important thing that I want to discuss. This is Simulink environment. In Simulink environment, with the help of the basic Simulink library, basically we are doing some mathematical modeling. What is by meaning by mathematical modeling and what is the difference in physical modeling? We are going to understand. Okay. So this is Simulink. So let me just how you are going to design any system. So just from the library drag drop the component in this one. So let me just for example, I take one this sine wave here. So I can just drag drop or I can insert this. Right click on any component, so it will automatically go to this model window here. So today's session goes up to around 4:30 for participant in the because.
Yes, sir. Yes, sir. No issue.
Just how you are going to insert your component into this model window. There are two methods. You can right click, or maybe three methods. Right click and add the component into your model window, or you can just drag drop the component. Just pick and drop in this one. So this component is there. But in the latest version of MATLAB, like this feature is came 2 or 3 years back. If we know the component name or some related name, directly we can also search the component here previously. Okay, but in the some latest version we can directly search the component if we are going to double click on this model window. Okay, now if we know the name of the component, so how you are going to know the name if you are just doing the practice. So if you require, so we can just type the name here. So suppose I am just going to use the integrator. So this is the integrator. Or I can insert some type of amplifier. So this is gain. Gain is a block which is used for amplifications purpose. So this is gain. So this is the whole process that how you are going to insert the component. Now, if you want to display your result, so I have two options. So using the display component which is in the this library. This is I think. And we can also insert, this is I think the component from the Android. Okay. So we are also going to discuss. So scope is used to display your. So now I'm just going to make a small circuit and I want to verify. Okay, I have inserted. So I can rename any component, just click and I can resize any component. Suppose this is multiply is going, so I can rename it as a amplifier by just click on that. I can resize. If I'm just going to insert this space bar, so all the component will display in the full window, full screen. So now how you are going to connect? Just if you are going to take here and just pressing your mouse here, so you can this wire automatically will generate here. Again, just I am holding the my mouse and this is connection. So we can connect. If we drop our connection in between, so it will show in the red color. That means it is not properly connected. Black color means here your wire is properly connected. Uh, Smartly, if you want to do a connection smartly, so what I can do, I can select my source component holding the control key and just click on your destination component. Again, holding the control key, just click on, automatically it will connect. Okay, so this is, I want to verify from the experiment. As you are aware that if some type of signals like sine wave, if I'm just going to pass through the amplifier, or I am also using my amplifier as a mic, so I want to verify that of my voice or this signal will change that if the signal is passing through the amplifier. So it is voltage changing. So I want to verify. So now this is my sine wave. So how you are going to edit the parameter or of any component? Just double click on uh, your component, and here we can the parameter right now. the amplitude of my sine wave is by default biasing. That means I'm not connecting any external supply. This is a sample time. If you are going to mention sample time here, this continuous sine wave will become your discrete sine wave. Okay. Now I'm just taking only amplitude as 2. Rest is only. This is my gain amplifier. So I have to mention the gain. So let us say it is 5. So now it will this sine wave, but I want to also compare the original sine wave also. So in the last old version, if you by default in the scope only I have one terminal, but in the old version, if you want to add the terminal onto your scope, so you have to just click on double click on the scope and manually you have to insert that particular terminal. Suppose from here also in the old version, I'm just talking about the old version. So from this setting, we can just enter the number of input of 3 or 2. So here in the old version, we have to just insert the terminal manually here. Okay. But in the latest version, let me just by default it as a but in the latest version this property also included into, but in the latest version just I am just holding the control key. If you are going to take carry a wire, so automatically this terminal is generated here. So here this is the new features of MATLAB. Now I can compare my original sine wave as well as this amplified sine wave, so that I can verify what property of my signal is changing. Is it voltage or frequency? So once you just complete your connection or inserting the, this is the option that we can run me. We are going to simulate our with different parameter conditions or whatever we have answered. So I'm just going to click on this run button, and this is my simulation time. Simulation time it is 10 seconds, but it is not real time. Okay, the simulation time or it may be your different time, but it will the 10. So it is compiling, this is compiling. So this type of block diagram in the background is solving and it will give me the result. So this is one type of system, easy system that I am going to simulate the behavior of the sine wave. I'm going to pass through the multiplier. So scope will not show you the output. You have to just double click on the scope, then it will show you. So why? Because in your circuit, you may have 5 scope or 10 scope. So once which scope output you require, you can just click on that and verify on that. So this is again my yellow is my original and this one. So I cannot again decide here. So no name is here. So if you want to write anything on the wire, so here just I'm going to double click on the wire. Double click on the wire. If you are going to double click on the space, so such window will open. So this is my sine wave. I'm just mentioning it. This is my sine wave, and let me double click on this wire, and this is my amplified sine wave. So I can write anything. Again, if you are going to any change in the circuit, then again you have to simulate. Suppose you are going to change the value or so now it is showing me sine wave, and now also it is not properly showing. We can also go to the tool, or we can also insert some options or zoom out, zoom out. Now I can also divide this whole scope into two window. So according to my requirement, I can display this. This is my original sine wave, and this is my amplified sine wave. So what is meaning by dynamic system? So dynamic system means if I am going to change this time as a infinity INF, so it will run for infinity time. Okay, so in the it will show me the behavior of my dynamic system. So now I can say that if I pass the sine wave or any signal to the amplifier, the frequency will remain same, only amplitude will increase. Here amplitude is 2 and here amplitude is 5. Okay, so this is one simple example. Now in some circuit diagram you will see that there is no scope is attached, but if you want to see your output, so still we can watch. So smartly we are going to make this diagram as a, so here I'm just going to use as a out. There are two components there, in and out. So if we don't want to use any output component, so we can terminate our output, and from the input in one we can also terminate our input. Now how you are going to see the result? Now I have the option that I can insert, right click here, and I'm going to insert this viewer and create a and connect viewer. So I'm just going to insert this viewer here. So this small portion, this viewer will be created here, and again here I'm just also inserting. Now I have two options, connect to viewer. So already I have this viewer. So I want to display both the things in the into same scope. So I want to connect this viewer also, or I can also create separate viewer for this. Okay, now I have this data inspector. Suppose I want to compare, I want to save different values. Different value means, suppose right now my amplitude is 2. My amplitude is 2, and I want to take, if I am increasing the amplitude as 5, then what will be the my output? So I want to save all the outputs from that. So now I have the option that I can insert or log the data. So this one, log selected signal. So I can just insert here log selected signal. So let me just click on that, and I can open this data inspector. So using this data inspector, I can inspect my signal. I can save or different type of signals in. So right now, this is, I have this one. Right now I have this one. And if I am going to change the value here, now I am going to run again.
सर आपकी वॉइस
Yes, sir.
क्लियर नहीं आ रही है सर, फिर से डेटा इंस्पेक्टर रिपीट कर दीजिए क्या, व्हाट इज
Okay,
डेटा
okay.
इंस्पेक्टर?
Now it's fine. Now it's fine.
यस यस नाउ फाइन सर.
Okay, okay, okay. So this is that, suppose you want to save your we can say, if we are going to change the value in any component, and for a specific value it will show one output, and now you want to display the, or you want to save the result from the different parameter values. So we can insert this log sign, this log parameter. Okay, and using the data inspector from here, we can just, now I am just changing the value. Now just let me just open data inspector. So now I can see both the value here. Okay, this one also, this is output signal, so that in the signal also amplify signal sine wave. Both value. These two, if I have the amplitude, this is my output, and then I change my amplitude as a 5. Now this is so I can the inspector, I can compare and save or log my output value or any value here. Okay. So this is how you are going to start with the Simulink. It is just for your what is the property and how you are going to build the models. Now come to our topic, that first there is no, suppose I want to analyze some electrical circuit or some electronic circuit, but there is no component is available in basic Simulink library. For example, RLC circuit I want to implement. So how you are going to implement this RLC circuit? So there is one technique is available. So as you know, if you have the system of RLC circuit in your theory classes, you have developed some type of apply some KVL, then you get some type of ODE equation from that one. Okay. So basically what is that? This system you are going to implement into Simulink using that equations. So as you know, what are that equation? Maybe dq by dt or plus one, this one. So for every systems, you can create one type of ODE, and then if you have the ODE with you, we can implement that ODE into with the help of Simulink. So right now, let me just open one example, and you can understand better that how you are going to design your system if you don't have only this one. So I'm just example, and this is will denote you a RLC circuit, which is in Simulink. So to building your circuit with the help of basic Simulink library, first we have to derive the equation of any particular system. Then we can just so this is the equation. This is the equation or OD or PD we can say. If you are going to, this is series RLC circuit, then if you are going to apply some type of Laplace, so you will get this equation. So how you are going to implement, this is your RLC circuit, we can say one type of system, and how you are going to implement this system into Simulink. So what is the basic for that? That you have to, this is your second order equation, this is your first derivative term, this is this one. So how you are going to start? Then always keep your higher degree term into left side and raise one in the right hand side. So what this equation will become, V in minus RQ dot minus 1 by CQ and whole 1 by L. So this we can will become. So now how we are going to start? We can start it from here, from this wire. We can assume it as a Q dot dot. Now, if you are going to pass your Q dot dot with integrator, so it will give you Q dot, and then another integrator, it will give you Q. For example, if you are going to pass your acceleration to the integrator, it will give you voltage, velocity, and another integrator, it will give you speed. So in this case, this q dot dot double derivative after the one integrator, it will give you. Uh, it's your choice that we can connect two integrators separately, but there is one component in the MATLAB that second order integrator also available. So we can directly connect it. One part will give me this only q, and this will give me q dot. Now, what is my equation?
Sir,
V in my, yes sir.
sir, what is Q? What Q is showing? Q.
Charge here, sir. This is basically RLC circuit.
Okay, 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 okay,
dq by di by dt. This is charge.
okay, okay, okay.
Okay. So here q and q dot. Then what is my equation? Mathematical equation v in minus r q dot. So in this is only q. So in q I have multiplication of 1 by c. So this is my gain. This is gain. I can multiply it 1 by c. But in the MATLAB, I have to mention the value of 1 by c. There is two method. I can mention this value in the workspace, or from here also I can create c variable and put the value here. So basically, I can use this value from here also. Okay. So this is already defined, this value. Now here R, what is R? R dot into Q dot. So Q dot is coming, so this is R. Now whole term is multiplied by 1 by L and V in is plus, otherwise rest is V minus. So mathematically we can connect. Suppose you are designing some type of electrical motor. So in the electrical motor, or we can say in the motor, we have two domain, electrical part as well as mechanical part. So you have to derive the equation for both domain, then you have to connect. So what about if your system is going to very complex, like if you are going to design the some type of electrical vehicle. So it is that you are going to derive the thing. So it is not possible for engineers that with the help of this Simulink ODE, we are going to create the system. So that is the problem. Okay. But this provide you the base. Okay. Now on the top of the Simulink, we have other library also. This is called the Simscape library. So let me just switch here. If I have the top of the Simulink, we have other libraries like this is called the Simscape product family. This is our Simscape product family. So Simscape, basically these components are made up of the one type of language. This is called the Simscape. So here on the top of the Simscape product family, we have 5 product is available. One is basic Simscape. So in the basic Simscape, we have basic component related to electrical, gas, hydraulic, mechanical, magnetic. But these are the some basic component. But if you want to work on some specialized domain like electrical, library is available. So electrical and electronics component are given in this library. This is called the Simscape electrical, like all the passive component, your diode, ICs, semiconductor, sources, and these are the utility components. If you want to design your drive line, so another product is this is drive line. So with the help of that drive line library, we can design and simulate rotational as well as. So if you want to design your rotational or translational component, so these are the clutches. Suppose you are going to design one type of vehicle. So here we have the another like fluid. If you want to use the fluid, so like that cable you want to design the JCB. This is for it, but these components are different. Connecting. So to connection these component we require some type of converter. Okay. So now we just let me open another example. And this is the same circuit of RLC, but it is made up upon with the help of, okay, understand? So basically in the Simscape we are doing physical modeling, and in the with the help of the Simulink component, base family on the top
सर
of the Simulink, but it
सर
yes sir.
सर वॉइस नहीं आ रही है सर, ये प्लीज रिपीट अगेन सर, ये
Okay,
RLC
okay.
सिम escape modeling sir.
Yeah, okay sir, now it's fine.
Yes sir.
Okay, so what is this Simscape library basically? So this Simscape library we are going to use for physical modeling, because in the Simscape we have the physical component is available. Whatever we have the component like motor, resistance, battery, everything is available. But these components are designed with the help of one type of special type of language. This is called the Simscape language. So we cannot directly connect Simscape component and Simscape component, but we
हेलो सर, हेलो, हेलो
yes sir.
सर, वॉइस नहीं आ रही सर आपकी सर।
क्या हुआ सर, पता नहीं। अब ठीक है सर?
नहीं सर, अभी भी बहुत लैग कर रही है वॉइस। हेलो।
हेलो।
हाँ सर।
हाँ सर, अब थोड़ा बेटर है।
हाँ सर, अब सही है। सर फिर से सर ये आरएलसी सिमस्केप को एक्सप्लेन कर दीजिए सर। वॉइस
ओके
क्लियर
ओके ओके।
आ रही। यस।
अभी आ रही है ना सर? पता नहीं क्या हो रहा है सर, थोड़ा हो सकता है नेटवर्क इशू। ओके, so same RLC circuit we have seen in the Simulink with the help of the Simulink, and this is the Simscape. So Simscape is a product family on the top of the Simulink which has some schematic component. So from where we can directly use this RLC or other component. So board diagram, or we can say board circuit, if you are going to run, as you know, the Simulink component and this Simscape component are made up of the different technique, we can say. So if you are going to, this is RLC circuit, this is battery, so we can see take this battery from the sources category of the Simscape. This is resistance, so we can take resistance, inductance. So like in your theory book, we can directly connect it. And this is voltmeter. So we can also connect it this voltage sensor to measure the voltage drop across this capacitor. But there is some extra component is given here. Okay. So what are these extra component? This is electrical reference. As you know, you are going to measure your voltage with reference to some type of building multi-domain system. So in each domain, we have some type of reference. It is for electrical reference. If you are going to join the mechanical system here, so we have the mechanical reference. So you have to always um, include this. But this is another, this is called the solver configuration. As I have discussed that we have different solver configuration. So for these type of circuit, we require different type of solver. So we have to insert this solver configuration block in each circuit. Okay, once we can connect it any corner. So this is extra component we need to. Basically, it has some solver configuration to solve this type of. But in the Simulink part, we don't have this one. Okay, so we need to insert this one. Now, this is voltage. It will measure the voltage, but I want to display this voltage onto this scope. But I cannot connect this voltage sensor and scope directly because this is a Simscape component and this is the Simulink component. Okay, so I need a converter. So in the library I have here, let me check here. In the library, Simscape library, in the utility library, I have these component like solver configuration. I need to insert if I'm using two domain system, like one is mechanical and one is electrical. So I need to insert two solver configuration for each domain. And these are the converter, PS to Simulink converter and Simulink to PS converter. If I want to convert my signal from physical to Simulink, so I need to insert this PS converter. If I want to connect or I want to take signal from Simulink to PS converter, so I need to connect. So this converter is always I have to insert. So this is the difference. It will give me the same result. So I hope you understand this, that what is the difference in this one. So using these courses, Simiscape, so this is the main difference, that how you are going to connect. Now, further, I'm just going to discuss another demo, that further how you can build some type of complex system. You can also design some type of controller or for your system. So let me just open it, and this is the example from a we can say the DC motor. Okay, now how you can build this type of DC motor? So I have just taken this example, that this DC motor has been designed with the help of the Simulink as well as Simscape. So I have both model here, and both model will work same here. So this is DC motor. Let me just open this motor as a Simulink model. So what is inside this Simulink model? This is, so this is a DC motor, but it is designed with the help of Simulink component. So to design mathematically, what I need? First, I have to derive these equations for electrical domain as well as mechanical domain. Then mathematically, I can connect these. So this will become my DC motor. Okay, got it? Same DC motor. Now, if I have this, I want to design this DC motor with the help of Simiscape. So this is the DC motor. You know, DC motor has the electrical as well as mechanical domain. So this is the electrical part of the DC motor, and this is mechanical part of the DC motor. So electrical part has some blue component color. This mechanical part has this one. So this is the DC motor directly we can use. Okay. So nothing is new here. Okay. So how you are going to create, after creating this one, you are going to create here this block. So we can convert any type of system into a single subsystem. If you are going to just select this one I'm going to select and right click on this one, and we can create any system into a subsystems into single block like this. Okay, so this is also created like this. So here, after creating, and we are going to give same output here. Okay, so both the, if I'm going to run this, both the will give me the same output. One motor I have designed with the help of the Simulink component, and another from the Simscape. Approach is different, but we can design, and it will give me the same output. So we can design, but if you are going to design your complex system, physical system, so we are going to use library of Simscape. So it is not possible. So in the Simscape library, once you know to connection from the Simscape library, so now you are able to design any systems like electrical vehicle, or if you have the domain knowledge related to electrical vehicle, or rotational system, transmission system. So this is the basic, that how we can design or make some. Further, we can also, if I'm going to run it, so it will give me the same result. So this is the Simulink motor, and this is the Simiscape motor. I can display on the, and this is the Simiscape motor. So it will give me the same output. Okay. Now I can also design the controller for my system. So I know I have the PID controller in my this one. So here let me just open this also. So I can control the speed of the motor by designing the PID controller. So in the MATLAB, this is the PID controller. So I'm not going to theory. So for PID controller, if I want to design this PID controller, let me just click on this. So this is the PID controller, and in the Simulink we have the option of tuning it automatically. Okay, automatic tuning means to designing a PID controller or PI controller, it is not possible that manually we can find out the value of P, I, and D. So, but in the MATLAB we can design that particular PID controller automatically. So using the tuning of this one. So before, just let me just run it before as a default. So I want to control the output of this one. So it is showing me that something, maybe I have just only designed, but if your reference output or this is the velocity and this is demanded, so some fluctuation is there, but initially maybe this value have different. So how you are going to tune your PID controller using this tuning option? So just click on this tune. Right now value is perfect here, so let me just click on this tune method. So it will open a PID tuning app. So with the help of the scrolling your speed, you can adjust the speed of that particular PID controller. And once the output, your reference output or your output is matching, that you can say that these are the value, final value of my PID or PI controller. So easily we can also tune our PID controller with the help of this one. So this is for that. So it will open up this one. So we will discuss now. Please, if you have the question, ask.
Students, you have any query regarding this Simulink model, Simscape model? Students, okay, sir. I think students have no query.
Okay. So let me discuss what are the different resources further. Now I hope you got idea about the MATLAB, Simulink, and some type of physical modeling, like to how you are going to design your complex system. Okay. So
Yes, sir.
so for that now you require some hands-on practice. Okay. So if
Yes.
just you are doing listening and nothing doing, so you are not going to learn anything. So now I want to learn or discuss some courses that for basic MATLAB, what are the hands-on. So this is the PID tuner. So using this, I can just tune my controller and automatically I can update my PID value. So that I can easily tune my PID controller for that. Okay. So what are the resources available? First, you need to create your MathWorks account. Okay.
Yes, sir.
Let me just so we will take another 5 to 7 minutes. Okay, so because today's topic is, so tomorrow we will finish at 4 more. So,
Okay, okay, sir. No issue.
okay, let me just minimize this because during the sharing it. Okay, so little bit I want to discuss that how you are going to just.
Sir, please also include, sir, in today's session IoT with MATLAB, sir.
Okay, no, yeah, I'm just going to discuss that hardware interfacing or application, sir.
Yes, sir.
No
Yes.
issue. So that I'm just logging to this one. Okay, further I have this library. Okay, so if you want to interface your Arduino board with the MATLAB, so what you have to do, only you have to just install the support package for Arduino hardware. Okay, so how you can install the support package, Simulink support package for Arduino hardware? On the top of on the desktop, we have this add-on option. Okay, this go to this add-on option, and it will show you the hardware get hardware support package. Okay, so there are two support package, MATLAB and Simulink. So it's better that you start with the Simulink support package for the Arduino or Raspberry Pi. So it is free. So once you install this support package, just log in with your ID. Then if you are just going to the Simulink library, so in the Simulink library, you will automatically get this library here. Simulink support package for Arduino hardware. Okay. So this is the Simulink support package for Arduino hardware. Now we can get related to Arduino, and if we are going to connect our Arduino with the with our laptop or desktop, so automatically MATLAB will detect your Arduino. Okay, now how you are going to, let me just open the doc. So first we can start, we can open one example, and how you are going to building the project with your Arduino board. So once you install the support package of your Simulink support package for Arduino board, so in the document you will get this link, or let me just, it will take little bit time. Okay, in the below document, you will get these hardware support, okay, automatically. So whatever you are going to install, so it will show the list here. Okay, this is my Arduino hardware support package for Simulink. Okay, not MATLAB start with, if you know not, so there is some command you have to use. So always easy to start with the Simulink support package. Okay, so there is some documentation is given, and here is everything is given: setup and configuration, modeling, run on the hardware, and these are the some example is given. So for experiment, you can start with one example. So there are various example is given. So with your Arduino, you have different component. So we can directly, these are the different example is given, and how you are going to, you can open any example with this basic example, and everything is given here. And what is the prerequisite and how, just everything is given. Take your breadboard, connect your LED like this, and you can use this type of simulation. So first, we can say first, this circuit is, you want to blink your LED with the MATLAB. So always, then everything is given, library is given. Just start this one, and later on you can make some complex project. Okay, you can open this project directly, project or this circuit, and it will again open direct in your model window. Okay, now how you are going to deploy that particular code on the Arduino. So you need to learn some embedded C or other language. But here we can direct build this type of project, and no need to write any line of code here. Okay. So it will take a little bit time. So directly, just I want to tell you that how you are going to setting up any hardware with the Simulink. Okay. First step is you need to install the support package. When you install the support package, then this depending on your Arduino board or any other hardware also. There is support package also available for the Raspberry Pi or your smartphone also available. So you can see the list that what are the different hardware support package is available. So this is the Arduino getting started. So this is inbuilt example. Okay. So now if you are making your own example, so you are sending this signal on the pin 9. In the library, if you want to connect your LED on the pin 8, so we can just click on this one and we can edit the pin number. So in place of 9, I can edit anything. So these components you will get in the Simulink library. So once you install the support package, and this is the pulse generator. So I'm generating a pulse here like amplitude of 110, and after the before connecting to the we can also connect the scope here. Okay, so we can verify the result that my pulse generator is working or not fine. So I can also connect here, and after running this one. So main thing is that you are first you are going to set up your hardware. So from this option, hardware setting, how you are going to tell to the Simulink that particular hardware I am going to connect. So by default, if you are making and you will make this in a blank model window or so from this configuration setting. First, by default, right now, maybe this hardware is already set here. But in this configuration setting, on this hardware implementation option, you can select from this option your hardware. Okay. So you have to select your hardware. Now by default it is Arduino Mega because it is inbuilt example. But if you are making your own, so we have to select our hardware. It could be your Raspberry Pi. So first we have to select our hardware that we can also do some type of device details. So from here configuration parameter we have to select our hardware. Okay. Now your this your Raspberry Pi is sorry, your Arduino is connected. Now we can run the program, monitor and tune, and we can see that our program is reflecting in our Arduino. And this is build and deploy and start. So build and deploy and start. So only build means we can generate the code, and build and deploy start. We can permanently deploy that particular code onto the hardware. It may be any hardware. So this is the process that how you are going to start with the Arduino. So just let us start. If you will face any problem, so you can just contact us. Further, for the IoT, what is the IoT? That means for IoT, you will get this thing speak library. So in the document also, so how you can start IoT means here I've just not supported. Yeah, you have to also install the support package for IoT. Okay, so I have not installed ThinkSpeak support package. Once you let me check if it is by default in the library. Maybe now it comes. I think. ThinkSpeak. Are you able to hear Android? Okay, you need to install the ThinkSpeak support package. Once you install the support package, then you will get the library for ThinkSpeak. So once you have the component, now you are able to send your data from on the ThinkSpeak. So what is ThinkSpeak site? Let me just open the ThinkSpeak. This is www. .com. Okay, so this is the service. It is provided by the MathWorks. For this, first you have to create your ThinkSpeak account with the using your MathWorks account. Okay. Now, once you created your this account here, you can sign in, and here you can create your own channel. Okay, like dew point measurement. This is my channel. So according to your that we can create our own channel. So there is step by step. If you go to here in the support and the tutorial, so step by step everything is given in the form of some screenshot. So you can follow this support, and you are able to use MATLAB and this service for your IoT application. So get started with the ThinkSpeak here. First tutorial is like collect data in new channel. That means right now, suppose you don't have any hardware or sensor, but you can collect data in your channel from any public channel. So this is how we can collect. So once you created the support this one, so we can everything is given here. Okay. Now there is another options also, like everything is given here, like signing into ThingSpeak, my channel, then create a new channel. You can give the name of your channel. And now this is everything is written. So just follow this one, and now we can analyze the data of that channel. Once we just, so this is the code on the, let me just, this is the code that this is the read channel ID. Read channel ID means you want to collect the data from any channel. So this is the channel ID of that particular channel. So there are various public channels. So if they are free or public, so we can collect the data just entering. Writing key. This is ThingSpeak read. Using the ThingSpeak read command, we can read from our MATLAB also, or we can run this on this site also. So this is simple process that we can use this MATLAB for our IoT applications. So this is that just sir, just say to the student or to start with this IoT or Arduino. Then there is some reference example is given. Just start with that. So once you will do, you will learn everything.
Okay, sir.
Any other question or any concern?
Students, you are making project related to IoT on Arduino board. So you have any query regarding this? Students, you are not asking any question. Okay, sir. I think students have no
Okay,
query.
okay. So this is your task that just create your MathWorks account. If anybody doesn't have, so create your MathWorks account once. So let me just login into and how you can start this MATLAB on RAM. And I have already told you how you are going to start your Simulink on RAM. First, you have to install the MATLAB in your system. So just go here in my account section, and here I have the MATLAB online. First, you have to try. We can say it's possible that you know the MATLAB, basic of MATLAB, but you should complete this course. That means you will learn the new features also. That what is the new features in the. So this is that we can also use MATLAB online. I think I have just click on the MATLAB online. I have to click on my courses. Okay. So from here we can also access this MATLAB online. In some cases, if you want to use MATLAB online, so you can also use it. So this the course you have to complete it. Okay. These are the around two. This is 2 round course, and we can take the some video, and it is very interactive course. uh, you are going to access or complete this course using any browser, so no need to install the MATLAB. So everyone should try. So tomorrow you have uh, another session on this machine learning. So it's better that you complete this course before that. Okay.
Okay, sir.
So using this, everything you will learn. There is some solution is given or some hint is given. So it is very interactive course, but try it. Okay. So tomorrow session I will ask, and right now you are not speaking. So I know your name in the list. So by name I will call you like Ankit or Ansuman. So I can call anything. Okay.
Yes, sir. It is very good.
Okay. So tomorrow I will uh, just I will call you by name.
Yeah.
Okay.
Yes,
So,
sir.
okay, okay. So thank you. So query will come. I hope that you will ask some query after the completing this MATLAB on RAM, right? First time. So maybe some query arrives, or maybe tomorrow session the person will come from the MathWorks directly, and it's that. Please ask to other participant to join on the time.
Yes, sir. Yes, sir. Thank you, sir, for the such a good session. Uh, and tomorrow we will connect on 2:30, sir. So thank you,
Okay.
sir.
Thank you, sir. Thank you very much, and thank you all the participants. Okay, thank you, everyone.
Yes, sir.